First of all, I will go to the first problem. I guess all of you see here a football playground, yeah? And we choose this football playground to obtain this rule, which gives us the real physical length in terms of the number of pixels given as LP and the height of the airplane, as you can see. Why did we choose this football playground? Because it has standard, as you know, standard physical measures. For example, I think the diameter of the circle in the middle is about 19.5, or the radius actually, not the diameter, the radius about 19.5 meters. So we used the airplane, we took several photos in order to obtain the fitted function, which you can see here. The one in solid is the polynomial fitted to the measured data, which is given in blue stars, as you see. So we have our practical law for measuring areas. Next, if you look at the left, you have an image of a theater. In this image, we have several, as you can see, green areas. 1, 2, 3, 4, 5, 6, something like this, yeah? And we seeded those areas to our algorithm. Those are the initial seeds of our algorithm, and the rest of the image is seeded as a background. As you see, these red rectangles, they represent the background, the non-green area, which we are not interested in. So after that, we put our image, we fit this image into our algorithm, and if you look at the right, it's very obvious that the green areas are classified very clearly and very obviously. After this classification, we calculate the areas of those blue regions, which are physically they are green in real life, based on our derived practical law by counting the number of pixels, then calculating. We come now to the next problem I mentioned, which is the following. We have the same, exactly the same graph. It's an image of a theater in my university, University, actually. And here, as you can see, we are interested only in this green area. We want to calculate this green area. And the rest is we are not interested in. So what we did, we included bars of those green areas in the blue rectangles, which represent the background. And the red rectangle, which represent the foreground, then we applied those seeds to our algorithm. Sorry. So we applied. So, okay, I almost finished. Anyway, we applied this image to our algorithm, and as you can see here, the targeted area is classified very well, and the area is calculated again according to our practical law. For further work, what we can do, we can, let me say, use a better algorithm without human interference, because as you can see, as you noticed, there should be a human interference in the seeding of this image. We can also derive a more sophisticated law taking, let's say, the error into consideration. And finally, we may train some kind of a neural network to do all this business without our interference. Thank you very much. Any questions?
Okay, thank you, Dr. Naser, for your good presentation. Is there any question?
Firstly, thank you for your nice presentation. I'm Riyad from Karabakh University. I just want to ask, what is the benefit of identifying just only one green area in the shape, in the second shape? First question.
Let's assume that you can use this area for reclamation or for investment, and you are not interested in the other areas. Why do you measure the other areas? I will measure the area which I am interested in, okay? The algorithm will give me the output as a sum. If I put multiple green areas, for example, I will get 10 square meters. But I'm not interested in all those 10 square meters. I'm interested only in one. So what can I do? I have to classify only one green area.
So we are determining the area we are interested in.
Yes, it's a user choice. You choose how many pieces of green land you want to calculate the area for, and you input this as a seed for your algorithm.
Okay. Second question is our algorithm adaptive? How much it's adaptive with the lighting? For example, some dark photos may comes out to our business. How do we deal with different lighting?
Well, the algorithm is very adaptive, but it depends on what lighting you are talking about. If your eye, if a human eye, can distinguish in the picture, can distinguish the green area from non-green area, regardless of light, then the algorithm also can classify green areas. It's as much as adaptive. And thank you for your question.
Thank you very much.
You're welcome.
Is there other question? Thank you again.
Thank you very much.
So we can pass to the last one, the last presentation. I want to invite Nida Şimşek. Okay. And the presentation title is Using 3D BIM Model for Value-Based Land Share Calculation.
Okay, good afternoon to everyone. My name is Nida Şimşek. I'm a PhD student in Karadeniz Technical University in Department of Geomatics. Today, I'd like to talk about using 3D BIM model for the value-based land share calculations. In the first part, I will talk about land shares and its calculation process and problems. And in the second part, I will talk about using BIM models for value-based land share calculations. First of all, what's the land share? Land share is co-ownership rate of the land parcel allocated to each condominium unit. Both condominium ownership and easement right are based on the principle of establishing co-ownership on the buildings with the land share. And this share is required to be determined according to the unit's value in comparison to entire association. What's the importance of land shares? Land shares are very important because using grass in common places in a building, restoration, maintenance and protection costs are based on land share. Executive decision making in building, in the case of expropriation of the whole building, or in the case of demolition of the building, these are based on land share. And as you can see from the chart, if you have highest land share in a building, you pay highest, for example, restoration costs in the building. And once this percentage is established, it cannot be changed without court decision. It's very hard to change. Land shares have to be determined at the date of declaration. There are 3 steps regarding with the using of land shares from design to construction process. First phase, some papers, architectural construction projects, land share charts, layout, condemning unit plans are prepared. And then in the second phase, easement right is in Turkish irtifak hakkı as a security of the property right is established. In that phase, when the building at the sub-basement level, in second phase, landowners apply to land registry offices with the first phase documents, and these documents include land share papers. And after the completion of the building, in third phase, easement right title transforms to condominium right title. In that process, we come across some problems related with land share percentages. One of them is architectural projects are prepared when the building is not physical on the land surface, and projects prepared in the design phase don't include valuation determinants, and it is not easy to show their value on a 2D architectural project, and land shares are determined over the project documents